we are using prime factorization to check if a given number is divisible by another number. So given 60, is it divisible by 12 is the question. We can answer this using prime factorization is what we are trying to see. Now, these are the steps. So first is figure out the prime factor of the given numbers, compare the prime factors, and determine the divisibility. For example, 60 can be written as 3 into 20 and 20 can be written as 2 into 10 and 10 can be written as 2 into 5. 12 can be written as 2 into 6, 6 can be written as 2 into 3. Now, compare the prime factors. So we have 3, 3, okay, let me use different color. So we have 3 and 3, 2 and 2, 2 and 2. So we compared. Check if every prime factor of the divisor, so this is your divisor, is also present in prime factorization of dividend. This is my dividend, right? So all of this number, is it present over here? So answer is in this case, yes. If all prime factors of the divisor are present in the dividends factorization with sufficient frequency, that is 2, 2, 2, 2, 3, that is having enough 2's and here enough 2's, that should match. I'll explain with an example. So in the dividend factor is sufficient frequency. Frequency is the number of times. So again, I'll explain this part. If any prime factorization of the divisor is missing or appear fewer times, the number is not divisible. Let me explain the third part. So let us take up another example, 60 and 24. So 60 again is written as 2 into 2 into 3 into 5, while 24 will have an extra 2 along with 12. Now, this is the divisor and this is the dividend. Here we have 1, 2 and third 2, but here we have only 2 2's. So this is the number of times 2's has appeared in 24 is more than the number of times it has appeared in 60. And so 60 cannot be divided by 24 with a remainder as 0. So the frequency is more over here. The number of times, frequency means number of times. Particular number has appeared in 24 is more than that in 60. And so this is an extra 2. And so we can conclude that not divisible. Divisible, not divisible. Divisible, right? Yeah, not divisible. So that's what the third point means. See, first two points are quite simple. Given a number, prime factorize it, check them. So on checking, you have many possibilities. The number of all the numbers, basically all the numbers has to match all the numbers. You need to tally them. So you have a 2, you have a 2. You have a 2, you have a 2. You have a 3, you have a 3. So the bottom one is divisible, can divide the upper one over here. Here, I'm not able to tally it like 2 and 2, 2 and 2. This 2 is not able to match, so you can stop. Not divisible. Done and done. So let me show a lot more example. So 60. 60 again, here is 2 and 2, 3 and 5, while 9 is 3 and 3. So I can tally 3 and 3, but not this 3. So this is an extra 3. So the number 9 has 2 3's, but 60 has only 1. Therefore 60 is not divisible by 9. Okay, so that's one more example for you guys regarding the third step. So let's try this. You guys can pause. It's a very simple process. Prime factorize it and try it. So we have 84 getting divided by 14. The first step is prime factorization. So 84 can be written as 2 into 42. 42 can be written as 2 into 21. 21 can be written as 3 into 7, right? So 21, 42 and 84. While 14 can be written as 2 into 7. Now, instead of, actually, you know what, we can call this as tally, right? Let's tally. So 2 and 2, 7 and 7. So 84 is divisible by 14. Okay, guys. So we have 120 getting divided by 15. So if you guys want, you can do the tree diagram. 120 can be written as 2 and 60. 60 can be written as 2 and 30. 13 can be written as 15 into 2. 15 can be written as 5 into 3. So 120 is made up of 2 and 2 and 2 and 3 and 5. 2 into 2 into 2 into 3 into 5. While 15 is 3 into 5. So after prime factorization, what should you do? Just tally. 5 and 5, 3 and 3. Actually, you should start with this end. Therefore, 120 is divisible by, not writing all of that, by 15. Now, let's have a look at this. First question, 70. Is it divisible by 6? So 70 can be written as 7 into 10, which can be written as 2 into 5. While 6 is made up of 2 and 3. So when I tally, I get 2 and 2, but not 3 and 3. So clearly, 70 is not divisible by 6. Okay. Reason being, as 3 is extra, it's not the right language, and 6. So is 100 divisible by 14? First thing is 100 can be written as 2 into 50, 2 into 25, 5 into 5. While 14 can be written as 2 into 7. So on tallying, we have 2 and 2, but not 7 and 7. So same thing, not divisible, 7 extra. I'm writing it in a short manner. Okay, so we have 48 getting divided by 18. 48 can be written as 2 into 24. 2 into 24. 24 can be written as 2 into 12. 12 can be written as 2 into 2 into 3. I think 2, 4, 8, 16, 16 and 38. Sorry, 48. Yeah. While 18 is 2 into 9, which is 3 into 3. So as you can see, 2 and 2, yeah, 3 and 3, yes, but this is extra 3. So not divisible. Extra 3. And divisor. I think that should be the language in the divisor. Okay guys, so you can see prime factorization, I'm doing it without the tree diagram, but I'm using the same principle as the tree diagram, just that I'm doing it in my head. 36. So 72 is, is 36 2 is 72, right? 35, it is actually, let me show this though. The heading is wrong, actually. So let me make this as 38, I guess. 38, so that answer is, because we have an answer for this. 36 2 is, okay, I'm changing it here. Just a second, guys. Let me make this as 38 or something. Now it will be more practical. Yes, 72 getting divided by 38. So 72 is this. I'll do the tree diagram. 2 and how much, guys? If I divide this with 2, 36. I think 36 we already did. 2 into 18. 18 is 2 into 9. And 9 is 3 into 3. So we have 72 as 1, 2, 3 and 3 into 3. While 38 is clearly 2 into 19. 38 is 2 into 19. When we tally 9 and 9, there is no 19. And so you know the conclusion. Not going to write it. That's it. Okay. So okay, you can see that frequency, that is the number of times, also matters. If it's not there, it is not divisible. Basically, you guys tally. That's it. Just use a method of tally and you are done. You can use pencil while doing that.